All right. So this time we're going to talk about this design pattern. Actually, let's do that like this. This one is called observer and sometimes also named listener. Okay, so it's interchangeable. Whichever one you use, it doesn't really matter. It's one of them. Okay. Oops. Okay, sorry, I'm just pressing the wrong keys right now. It's annoying. There we go. So the observer design pattern, the listener design pattern, you've been already using it a lot of times without noticing it. One of those example is, let's say, let's go in our GUI. It's when a button gets clicked. So let's go down. I don't know where the buttons are. Okay, here we go. All these buttons I created. Create for starting, the stopping, to take off, to increase, decrease, doesn't matter. This add action listener over here. Basically, when my button gets clicked, I want to execute a specific function. This function being action performed. Right? So whenever one of these buttons is clicked, I want to execute this code in here. Well, how does the computer know that that button got clicked or know that you need to call this specific function or not? Right? This is where observers come in. Okay, and I'm going to teach you and then we're going to come back to here a couple of times. And the easiest way to teach you this is I'm going to give me 1 second. I know I took a picture of this. Give me 1 second to find the picture. Where's the picture? Okay, you know what? Let's just go grab Google, our best friend, and let's do design patterns. Actually, I already know the pattern. Observer pattern. Observer or listener is all the same. Okay, and I want to go with an image because this is all that matters. And let's take a good image. This one looks not bad. Subject, observer. Yeah, this is a good one. Sorry, I just want to zoom in for you guys. So, first thing to note, these are basically classes. Okay? And there's really like 4 things here. And that's all you need for an observer pattern or a listener pattern. The first thing we need is a subject. The subject is going to be the point, it's going to be the subject of interest, the point of interest, the object that we are staring at. So in the case of our Java application, the subject would be the button. And someone is looking at that button, and at any moment that button modifies, we want to notify all the observers. So the subject knows about all the observers. Okay? And what's going to happen inside the observer, there's a function that's always going to be there. In this case, it's called update. So whenever someone's interested into a subject, so whenever someone's interested into start motor, stop motor, into a button, they would register themselves. So the observer would register themselves inside the subject by calling one of these functions, attach or detach. And whenever the subject changes, it calls the notify. It will go through each observer and call that specific function update. Really, this is the only 2 things you need. Does that make sense? So the problem is you don't know who's the subject and you don't know who's the observer. It could be many different observers. It could be as many as possible. So what we need to do is we create 2 abstract class. In this case, we could make an interface where we enforce that they have these specific functions. And then it doesn't matter who the subject is, who the observer is. They're always going to have these specific functions. And they're always going to be, we could always use polymorphism to say they're observers. We don't need to specify which class exactly. And how they do it, they have to implement it themselves. This is why we make it into an interface. Okay, let's go a bit more in details. You're going to see this. We're going to come back to this. So just note a couple things. This subject and observer over here. Let me bring up annotation. This subject and observer that we're seeing here, they're both a interface class. And they're an interface class, so we could set some rules of what functionalities we need. Then we get this thing called concrete. This is your actual class that uses that. So concrete means the actual object or the actual blueprint class. Okay, that needs to be an observer, that needs to be a listener, or the concrete class that needs to be a subject. Who needs to be subject? And what's going to happen is, well, they're going to implement all of those functions. Implement all of those functions. Okay, let's go back. So before we start implementing, actually, let's look over here for a second. Let me get back to mouse. This button on our swing thing. Let me clear the screen here. This button on our swing, this, if we look inside, it takes an action listener. It doesn't care which one, but it takes an action listener. And remember, observer and listener is the same thing. Okay, it's just a different term for the same thing. One's looking, one's hearing. It's the same thing. So inside our design pattern, this action listener is basically our observer. So this thing is observer or listener. It's the same word, right? But we don't know exactly who's going to be the observer. So what needs to happen is on our concrete class, we need to implement this function. So if we go back to clicking a lot of stuff, there we go. If we go back here, notice that this class is implementing action listener. And if we go into action listener, really there's nothing in there except for action perform. This would be the same thing as our update, right? But in this case, our subject is a button, and all those people that are going to get, when the button gets clicked, well, an action is going to be performed, like a click event happens, etc. Okay, so this class is our observer or listener interface class. And we see that. And we're going to implement one soon. And when it gets clicked, let's go back to here. So, where's our button? Here. Add action listener. It doesn't take this specific object because right now we're in GUI. This is the object we're currently in. It takes a action listener. So it doesn't really know which one's coming in. Polymorphism, right? An abstraction. It doesn't know which. It doesn't really care. The only thing it cares is that whoever it is has the function action perform. And why does it need that? Well, if we go back here and we go look around, the first thing you'll notice, sorry, my computer froze. The first thing you'll notice is, we're going to come back to here one second, that this object, which is a button, is going to be an observable class. Okay, I don't see it here. It might be one of these other stuff. So, what's going on here? It's an observer class. Let's go back to, sorry, one second. Okay, let's go back here, add action listener. So it's an observer or listener ideology. So this is the subject. So if you look at the subject, it needs to have an attach. This add action listener is the attach. Right? And it's going to attach what? An observer and listener. Look at here. That's the previous class that we were on, the GUI. And obviously, if you could add it, you could also remove it. So that would be our detach, attach and detach. And the last part is notify. So when the button gets actually clicked, we need to go through each of those action listeners, each one of those observers, each one of those listeners, whichever term you want to use, and specify or call that function that we were looking at, which was action performed. So if we go look down through this, we will see a function somewhere. Let's say fire action performed, where you'll notice, actually this line over here, it's gonna go through each listener that they have. It's gonna typecast it to action listener. It doesn't know if it's a GUI, if it's a different object. The only thing it knows for a fact is there is a action performed object. Action performed function, method, an action that it could do. And that's all it does. Right? So knowing this, let's go ahead and try and create our own. So let's say over here, right now, our GUI, there's only one of them. And it takes care of the airplane by itself. So first thing first we're going to do is we're going to create an airplane. Actually, before I do that, I want to show you something. So let's say there's that GUI, and let's say there's another GUI. So there's the guy who controls the airplane, who's the pilot, and there's the control tower. So let's call it, let's rename this a bit. Let's call this one control tower, and let's call this one pilot. Right? So the pilot is at the cockpit, while the control tower is somewhere in the field, and etc. Now the first thing we do, we're gonna have a few issues. I'm gonna explain them as we go along. Well, first thing first, we get our pilot. Notice the title, and we get our control tower. Now they're both supposed to control the airplane. One is gonna be remotely, one is gonna be manually there. And let's say this is what's happening right now. So the pilot starts the motor. Well, we see no notifications inside the control tower that the motor has been started, even though this says. If he takes off and increases, well, nothing's being displayed. Well, fine. Let's say from the control tower, we start and we take off. Well, the first issue we notice is the values don't match. They never match. And this is because, if you guys could see it, if you look at line 12 and line 13, this is because what? Well, our object airplane is not actually the same instance. It's not the same airplane. These two are different airplanes, right? The new keyword. So each one of these GUIs is manipulating a different airplane. This could be the Boeing 747. This could be the Air CS 5000. So what we need to do first is make the same airplane used by both. So airplane, let's say Boeing 747 equals new airplane, and that's fine. And rather than creating a new instance here, we would give it the Boeing 747. Same thing here, Boeing 747. Now when I run it, I still get pilot control center, but the difference is, let's say I start the motor, this one could start taking off because the motor is already done. Could increase the altitude. Notice I'm at 6,000. The moment I press decrease on this one, you'll notice it shows 5,000. So now the problem is, it's the same airplane. They are manipulating the same, but the problem is what's being visually displayed to the pilot and the control center is not the same exact thing. They're not being notified the moment a change happens. They're being only notified when they make the change themselves. So this is a bad thing. Everyone with me on this part though? So what we want to do is we want that airplane to be registered as the subject. Sorry, 1 second. I needed some fresh water. So we want the airplane to be our subject. And whenever the subject changes, we want our GUIs, which are the observers, to be notified about any changes. Okay? So the first thing we need to do is to create our two interfaces, our subject and our observers. Again, this could have been called listeners, observers, whatever you like. And again, these rules are an idea. It's not concrete. There's no specific thing you have to follow. It's a great way of doing it, but you could modify it and manipulate it to make it a bit more whatever you like. So this design pattern is pretty cool. You'll see it a lot. You'll see it here. You'll see it in Android and multiple different areas. So the first thing we need to create, let's go ahead and create a new package. We don't really need, well, we'll create a new package. Let's call this one the Observer package. And inside the Observer, I need a couple things. So the first thing we needed was an interface called the subject, right? Public interface subject. And if we notice, we need a couple things. And this subject is specific to being the airplane. So a better way of doing this would have been to rename it the airplane subject, but for now we're going to keep it this. And a better way of saying it, you would be attaching, we know directly we would be attaching GUIs or, well, actually we don't know. We shouldn't say who's the observer, but we know we're always attaching someone to the airplane. Anyway, so inside our airplane, we need a couple things. Attach, detach, notify. So we have actually something we could do. Yeah, something cool we could do with subject, if you remember the differences between interface and abstract. Is abstract, we could implement some parts, and what the parts we don't want to implement and we want the concrete class to implement, we would make them abstract. Okay? Is there any errors? Public abstract class, subject, and inside that we're gonna have 3 functions. So let's say public void attach, who's going to be attaching an observer. So let's go ahead and create a new, we'll come back to this in a second. Let's go create a new Java class observer. Let's make it an interface. So we're going to attach an observer. We'll get back to that in a second. We want to also public, at some point, let's say your magazine, your website, at some point your user doesn't want to be notified about your website change, so you need to add a attachment. Yes, sir.
So could you repeat why again you used an abstract class over interface here?
So if we use an interface, the concrete class, which in this case would be airplane, would need to implement every function. Right? Abstract, in the other hand, you could have some stuff implemented and some stuff not, such as doing something like this. Public, abstract, void. Okay? In this case, I'm forcing whoever inherits from subject to implement this, and he will inherit this automatically. He doesn't need to override it. That's the cool part. Does that make sense? And you're going to understand more why I went with abstract rather than interface. And I might just switch it up to show you the difference. So we need to attach this observer and we need to detach this observer. To do this, basically, well, we got notified to do, but to be able to attach and detach, we need to have a list of all these observers. So what we could do here is to create a private array list of observers. We don't know which observer it is, but that's going to be all of my observers. And over here, we don't need to specify. Keep it like that. So when I'm attaching, the only line of code you need in here is to say all the observers dot add the specific observer. So I'm adding this guy into here. Right? So think about your website or think about YouTube channel. You're following this guy on Instagram. All of them are doing this. So whenever you press the follow, it's basically going to add you as a follower to that subject. The subject could be anyone. It could be any user. It could be any airplanes, etc. And whenever that person is tired of listening to that, let's say user, that website, that YouTube, that airplane, we would just say observers, remove that specific object by doing this. Right? So far, so simple. Now, it gets the interesting part. We're going to come back to this notify, okay? We're going to do that notify. Let's go to our observer for a second. And remember that an abstract class, you cannot create it. So abstract and subject, we can't create those. So if I say observer equal new observer, it's going to say, hey, you can't create that. If you want, I could make you an anonymous class, but this is not what it is. You cannot create anything that's abstract or interface, right? So same thing for my other one, which was called, forgot what it was called, subject. So let's say if I say subject, create me a new subject, it's going to give me an error saying you can't create anything that's, well, I didn't really, public abstract, so yeah, I can't create any of that. Okay, this actually, and we're going to import star. Okay, so I can't create subject because it's abstract, you can't create it. And I can't create observer because that's also an interface. Observer. Right, in both cases, you cannot create anything that's abstract or interface, which is also an abstract. Okay, and if again you don't remember the difference is abstract allows you to have partial implemented methods like we see here, while if I do this inside an interface, it would tell me, hey, you can't add the body of anything, you can't implement any methods, cannot have a body, right? So we could just say, hey, whoever inherits from observer must implement this function. And in the case of an observer, the only thing we need to do is to add the update function to enforce that an update function is there. Okay? So you name it whatever you want. In this case, because it's we're telling our GUIs that our airplane change, maybe we want to make this a bit more specific to our GUI and airplane. You would say airplane changed function rather than saying airplane, rather than saying updates. Okay, but for now I'll make it in the same as this image so it's not too weird. So here we're gonna just say updates, and that's it. So now if we go back to our GUI, well, actually let's go back to our airplane. We want to make sure that our class is inheriting from our abstract class subject. And because this is also a class, we're going to say extends. And we said this is the subject. Okay? And because we didn't mention any of, because we implemented the functions here, we don't need to implement anything in here. Right? There's one last one we're missing is the notify. So public void notify. And all is this one's going to do is going to go through the list of all each observer. So go through the list of observers. So for each one of them in my list, look here, I don't know what functions it has. The only function I know it has is update. And it's going to just call that. And that's it. And that's it for our observer interface, our observer abstract class. So whenever a change happens, we call this function notify. And it's going to go through each observer and let them know that, let's say the button got clicked, the website got updated, the Instagram added a new image on this user. And if we look inside our observer, that's the only function there is. So this gets interesting. Let's try it out. So let's go back to our airplane. We say we are the subject. Now the only big thing we need to do, is to call notify. Call notify whenever a change happens. And another thing is this cannot be public. No one else outside of my subject should be able to call this. So if I make this private, the problem is the one inheriting from subject cannot get it. So we want to have this as protected. So now, let's say in my airplane, which extends subject, I started the motor. Okay. As soon as I start the motor, I want to notify. So notify, and it's going to do it. So if we go to this class, if I hold down control, you'll notice this is the not correct notify. Which notify is this? Subject. I put a capital here for some reason. Let's put these A, D. I'm putting it lowercase because of Java. There's already one that comes from Java lang object. So can I override it? Override. There we go. Oh. Okay, so what we're gonna do is notify observers. Alright, so whenever a change happens, I'm gonna call notify observers. Or in this case, more thoroughly should have been notify. Well, actually, it's good. Notify observers. So anytime I have a change, I should call this function. And it has to always be called within the subject. So inside the stub motor, I should also notify observers. Inside the takeoff, I should also notify my observers. Increasing altitude is it's already being done, so I don't need to do it. Well, we don't need to do it twice. Check altitude, no, that's just checking, nothing to do with change. And decrease altitude, we should do it. And notice that it calls check altitude twice for increase and decrease. So actually, I'll just put it just to be sure. Okay. What's gonna happen is gonna go through the list of observers and call the function that we talked about, the function being updates. Now let's go in our GUI. We want our GUI to be just like our action listener. We want to implement our observer. Okay, usually you would name it something better to make more sense, like action listener or airplane observer or airplane listener or whatever. We need to implement the methods because they're not implemented yet. It's interface. So we do implement updates. You'll notice now we have a function update, just the same way we have a function action performed over here. Right? It's the same thing. So this is when airplane got changed. What should I do? Right? So if the airplane got changed, I need to update all my visual context, all the stuff I see visually. So if I could run this, let me see if I can run. So here I can't create these. We were talking about this. So if I run it, we got the same airplane, right? But now when something happens in one, let's say it starts and then it increases altitude, or sorry, it takes off, I need to notify all the observers. And I did. Actually, let's go check that out. Let's go back to our, let's go back to our GUI. Over here, this function is being called, just nothing's happening. So system.out update called, right? Let's run this, try it out. So I have two of them. Let me put them here so we don't block. So as soon as one of them gets started, the motor, right? And then I take off. Oh, I forgot to do something. This is why it's not showing. We forgot to attach them, right? So if we look at subject, we need to attach whoever wants to observe. So let's go to our main. And I have these two GUIs, but now I need to attach them. So I need to create a GUI object, well, I need to create a reference to it. So let's say this is the pilot. And over here we have the control tower. And then I go again and I do Boeing. Attach. Who's observing it? The pilot. Boeing. Attach. Who's observing it? The control tower. And I can remove them anytime. So now if I run it, actually before we run it, go inside GUI. So we have our control tower and we have our pilot. If the pilot says start motor, notice update is being called twice because there is 2 observers. Right? The update called value here. So what we need to do now, knowing that the airplane got updated, we just have to go look at the values and update our screen with those specific values. Right? Any questions? So, what we need to do, let's say an action performed. What do I usually do? We increase it. If we did, we check the text. Whatnot. The text we could ignore, but let's say I'm trying to remember what this code was doing. So set foreground color black, blah blah blah. We don't really care. If we start the motor, it just says these things. So one thing I could do is go through all the list of states for my airplane, and based on the states I show the correct thing, but I'm not gonna do it because it's gonna take time. What I do want to do is, if I increase the altitude, right? If I increase the altitude, I want to show the increased altitude like I was doing here. So 1 second, start motor, increase altitude, take off, increase. I want this thing to be modified, right? So let's go and see where is that thing. Panel, no, button. That should be set east, so it should be in the west. Where's the west? You have a J panel, a J label. LBL current altitude and altitude progress bar. Thank you. So these 2 are the things I want to change the value, okay? So let's go back to our function. LBL current altitude. I'm going to set that text to airplane dot get altitude. Okay? And what's wrong? Okay, it's a string. We're going to do a super quick casting here. We're just going to cast it to string by concatenating. Okay? It's the same thing. So because this is a string concatenated with anything else, it would always be a string. So that's the first one. The other one is the altitude thing, altitude progress bar. We want to set the value to airplane get altitude. Cool? So now, again, we could have done a lot more here. I could have checked the status, the state of the airplane, showed it all. But let's just for visually to understand. So if I start a motor and I take off, notice that both, they go up. This one doesn't have the information because the only stuff we're updating right now is the altitude number here and the progress bar, which is this thing. So if I increase it here, notice that they both increase. Actually, it's not decreasing for, there's a problem here. I bugged out. It's not, for increase it works, but for decrease it's not, seems to work here. Yeah, so there's, I forgot to do notify an airplane. So here for decrease we did this, but for increase we forgot to do it. There we go. Right? So this notify observer is important because it's going through the list of the observers and letting them know that some change happened. What that change is, well, we could have done it a bit better. We could have said, well, actually, we'll come back to that. Okay? So now we could run it again. We'll come back to that. Again, this observer class is an idea. So we're going to modify it, make it adjusted, so on. So now if we start in 1, The other one doesn't really know it started because I don't really do anything other than these two things in update. But now if I take off, you'll notice that both are going to change. If I decrease, they're both going to change. If I take off again, increase, I increase, I decrease, increase, right? They're both changing. And this is what a observer class does. Any questions? So again, I should check if it's 10,000, make it yellow, put that warning. If I reach 12,000, well, it should have shown me that boom right away. Right? But this comes down to here putting if statements and whatnot the same way I did it inside my action before. Any questions? So I need a bit of break. My voice is cracking up. As soon as we come back from the break, oh, someone asked, can you explain how observer update works again? So yes, so if we look inside here, we need to specify who our subject is. In this case, our subject is airplane. Our subject is airplane. We need to specify who observers are going to be. And in this case, we made our GUI our observer. Now, for the subject, which in this case is our airplane, we attach and detach observers. So attach as in they're interested in knowing any changes. So whenever a change happens, notify them. Detach is, hey, I'm bored of this. I don't want to know about it anymore. Good example of this would be websites where you register for newsletters. A great example is your Instagram. You're all using it. Whenever you follow someone, you're attaching inside their list of followers. Same thing goes for their detach. The moment that you're tired of this guy, he's putting some bad stuff in there, you say unfollow this character and you're never going to see any information from them again. Now, knowing that this is attaching observers, right? We know for a fact that observer class, whoever is an observer, has a function called update. So if we go look here inside our subject, whenever a notification happens, we go through the list of our observers and we know for a fact it has an update. So if we look at our GUI, we know for a fact it has a function called update. Why? Because it had to it had to implement it. It was forced to because of interface. So what's happening is when a change happens, go through each of those observers, call the update. So inside observer, inside subject, we're going through each observer, we're calling the update. The update is going to call this function, and in this function you do all the stuff you need to check. Now, if we go back here in the subject, when would this function be called? Well, that is up to the airplane to specify it. So if we look inside our airplane, which is our subject, at any moment I feel that something should be notified to people, I call the function notify observers. I call that function, it goes through a for loop, it calls every observer dot updates. Same thing for stop motor, same thing for takeoff, same thing for increasing altitude, same thing for not check altitude, that doesn't change anything. Decrease altitude. For anything that would cause a change to my states. Cool? And after we take a little break, I'm going to come back and we're going to make this more of our type of class. But this is already an observer pattern. And you see, it's neat because whoever registers or deregisters, they don't have to check the airplane every second, every minute, has there been a change. They will be notified at the moment of a change happens. And this is really powerful because the previous version where you keep on checking every state to see any changes would be costly. If you have to do 60 calls per second, that's a lot. If you make it slower and you call 1 time per minute, you're still making a call that you don't need to make. And in the case of an observer pattern, the calls are only done when the change happens. So that's powerful. Any other questions? So let's take a break, and after the break, we'll modify our observers to be a bit more, to give us a bit more idea of what's changed. Right now, we don't know what's the change, so we kind of have to do everything here and check everything, and it's not the perfect thing to do. Right? So let's take a break.